B. Laundry and electric company, an example. An injunction may appear to be an absolute proscription on an act. For example, if the court were to enjoin the future invasion of the farmer's cornfields by the rancher's cattle, one might interpret that as meaning that the rancher will have to erect a fence. This is a mistake. The injunctive remedy does not prevent the invasion of the farmer's property by the rancher's cattle from ever occurring, only from its occurring without the consent of the farmer. The farmer is free to make a contract promising not to enforce the injunction. To illustrate, the farmer might agree not to enforce the injunction in exchange for payment of a sum of money by the rancher. Superscript 18, it reads, uh, this inducement to bargain may be more theoretical than real. For a discussion of research by Ward Farnsworth about post injunction bargains, see the material at WebNote 4.2 on our website. Given these facts, the right to an injunction should be regarded as a clear assignment of a property right. Once the property right is clearly assigned, the owner may strike a bargain to sell it. If the court enjoined the rancher from allowing future invasion by her cattle, this could be viewed as a declaration that the farmer has the legally enforceable right to be free from invasion by cattle. If the rancher's value on being allowed to invade the farmer's property is greater than the farmer's value on being free from invasion, there is scope for a bargain in which the rancher buys the right from the farmer. Most legal disputes are settled by bargaining between the parties without going to trial, but the terms of the bargain are affected by the remedy that would be available at trial. Superscript 19, it reads, this is referred to as bargaining in the shadow of the law. Specifically, the terms of the bargain are different depending on whether the remedy is damages or injunction. An example from chapter 1 will help you understand the relationship between remedies and bargains. Facts. The capital E Electric Company emits smoke which dirties the wash at the capital L laundry. No one else is affected because capital E and capital L are near each other and far from anyone else. Capital E can abate this external cost by installing scrubbers on its stacks. And capital L can reduce the damage by installing filters on its ventilation system. The installation of scrubbers by E or filters by L completely eliminates the damage from pollution. Table 4.4 shows the profits of each company depending on what action is taken to reduce the pollution. The profits that are shown in the matrix include any compensations that might be paid or received as a consequence of a legal dispute. Table 4 is profits before legal action. with this double cross symbol, and that reads the electric company's profits are given first in the lower left corner of each cell, and the laundry's profits are given at the upper right corner of each cell. So it's on the vertical side, vertical columns, we have no filter and filter. In the horizontal, we have no scrubbers and no scrubbers. See the graph. The numbers in table 4.4 can be explained as follows. When capital E does not install scrubbers, its profits are $1,000 regardless of what the laundry does. When capital L does not install filters and does not suffer pollution damages because capital E has installed scrubbers, capital L's profits are $300. Pollution destroys $200 of capital L's profits. Capital L can avoid this by installing filters at a cost of $100, or capital E can avoid it by installing scrubbers at a cost of $500. Check to see that you can use these facts to explain the numbers in the table. The most efficient outcome is, by definition, a situation in which the total profits for the two parties, called the joint profits, are greatest. The joint profits are found by adding the two numbers in each cell of the table. Joint profits are maximized in the northeast cell, where $1,200 is attained when capital E does not install scrubbers and capital L installs filters. The harm caused by pollution represents a source of contention between capital E and capital L. They may be able to settle their disagreement and cooperate with each other, or they may fail to cooperate and litigate their dispute. What we are interested in determining here is how the remedy available from a court may induce the parties to achieve the efficient solution and thus to minimize the harm of pollution. Suppose that capital E and capital L litigate their disagreement. Three alternative rules of law could be applied in the event of a trial. 1. Polluter's right, capital E is free to pollute. 2. Pollutee's right to damages. Capital L is entitled to compensatory damages from capital E. Compensatory damages are a sum of money that capital E pays to capital L to make up for capital E's reduced profits due to capital E's pollution. 3. Pollutee's right to injunction. Capital L is entitled to an injunction forbidding capital E to pollute. An injunction is a court order requiring capital E to stop polluting. Let us determine the value of the non cooperative solution under each of these rules as depicted in Table 4.5. Beginning with Rule 1, if capital E is free to pollute, the most profitable action for capital E is not to install scrubbers and enjoy profits of $1,000. The most profitable response for capital L is to install filters and enjoy profits of $200. Thus, the non cooperative value of the rule of free pollution is $1,200. This is the efficient solution, which is in the northeast cell of the table. Numbers in table 4.4 are in the top left corner are 1,100. In the top right corner, 1,200. In the bottom left corner, 500 and 300. And on the bottom right, 500 and 200. Table 4.5, profits from bargaining under three legal rules. On the vertical axis, we have Rule 1, polluters' rights. Rule 2, damages, next line. And then the next line, Rule 3, injunction. And across, we have non cooperation and surplus and cooperation. So under polluters' rights, Rule 1, E has $1,000 and L has $200. Under non-cooperation, there is zero surplus, and with cooperation, you have the same outcome: 1,000 for capital E and 200 for capital L. For Rule 2 damages, you have non-cooperation. Capital E has 800, capital L has 300. There's 100 in the surplus. And in cooperation, capital E has 850 and capital L has 350. Under Rule 3, injunction, non cooperation has 300 for capital L, listed first this time, and 500 for capital E. In the surplus, there's 400, the most surplus. Now in cooperation, you have capital E, 700, and capital L, 500. Turning to Rule 2, assume that capital E must pay damages to capital L. And also assume that capital L has no legal duty to install filters, no duty to mitigate. If capital E must pay damages to capital L for polluting, then capital L will not bother to install filters. Capital E will have to pay damages to capital L equal to the difference between the profits capital L enjoys when there is no pollution, $300, and the profits capital L enjoys with pollution, $100. Capital E has a choice between installing the scrubbers and paying damages of $200 to capital L. The more profitable alternative is for capital E not to install the scrubbers. It initially realizes $1,000 in profits, from which $200 must be subtracted to pay damages, leaving capital E with net profits of $800. Capital L enjoys the profits of $300, open parentheses, $100 from its operations plus $200 from capital E. The non cooperative value under Rule 2 A rule of liability for compensatory damages is the $1,100 equals $300 plus $800. This is the value in the northwest cell in the table. Turning to Rule 3, if capital E is enjoined from polluting and responds by installing scrubbers, capital E's profits equal $500. When capital E installs scrubbers, capital L will not bother to install filters. So capital L's profits will be $300. Thus, the non cooperative value under the rule of enjoining pollution is $800 equals $500 plus $300, which corresponds to the southwest cell of the table. Under the pessimistic assumption that capital E and capital L cannot cooperate, only one of the legal rules produces an efficient outcome, namely Rule 1. Instead of making the pessimistic assumption that the parties will be unable to cooperate, suppose we make the optimistic assumption that the parties can settle their disagreement cooperatively. We are assuming that transaction costs are very low. When capital E and capital L cooperate, their best strategy is to maximize the joint profits of the two enterprises. The profits are maximized when they take efficient course of action, which in this case is for capital L to install filters and capital E to not install scrubbers, yet yielding joint profits of $1,200. This is the efficient solution in the Northeast sale. There are thus two ways to achieve the efficient solution. One way is for the law to adopt the rule for which the non cooperative solution is efficient. This solution is compounded by the normative Hobbes theorem in our example, but not necessarily other pollution examples. The non cooperative solution is efficient under Rule 1, which gives capital E the freedom to pollute. The other way to achieve efficiency is for the parties to cooperate. The cooperative solution is efficient under all three of the possible laws, according to the Coase theorem. Efficient allocations of legal rights by laws, such as Rules 2 and 3, will be cured by private agreements, provided that bargaining is successful. If transaction costs equal zero and successful bargaining can cure inefficient laws, what difference does the law make? One answer is that the law affects the distribution of the cooperative product, which affects bargaining. To illustrate this point about distribution, recall how the structure of the law, such as rules 1, 2, and 3, affects the threat values of the parties. A reasonable bargaining solution is for each party to receive his or her threat value plus an equal share of the cooperative surplus. Each party to a bargain would prefer the rule of law that provides him or her with the largest threat value. Specifically, the threat value of the plaintiff in a property dispute is at least as great when the remedy for future harm is injunctive relief as when the remedy is damages. The plaintiff consequently prefers the remedy of injunctive relief for future harm, or better yet, injunctive relief for future harm and damages for past harm. In contrast, the defendant prefers the damage remedy for future harm, or better yet, no remedy. The effect of the rule of law on the distribution of the cooperative product can be computed precisely for capital E and capital L. Imagine that capital E and capital L enter into negotiations, and to keep the arithmetic simple, assume that negotiating a settlement or going to trial is costless for the parties. Swallow hard the non cooperative payoffs, that is, the profits the parties can get on their own if negotiations fail, are shown in Table 4.5. Under each of these three rules, the cooperative surplus, which equals the difference between the joint profits from cooperation and the threat values, is shown in the middle column. A reasoning bargaining solution is for each party to receive his or her threat value plus half the surplus from cooperation. The payoffs to the two parties from cooperation are given in the two columns on the right side of the table. Notice that in each case, the cooperative payoffs sum $1,200, but that capital L receives the largest share under the injunctive rule, Rule 3, and intermediate share under damages, Rule 2, and the smallest share when capital E is free to pollute, Rule 1. Question 4.12. In the preceding example, implementing an injunction to end future interference costs the defendant more than damages for future interference. Is this fact generally true or just a special feature of this example?